Hi, good day to you, and thank you for taking the time to view our web demonstration today. My name is Marcus, and I'll be your application specialist taking you through today's web demonstration. For today's demonstration, we will actually be demonstrating the TracerM laser projector, and I will give you a quick look at the product. So as you can see in your camera feed right now, the TracerM laser projector is currently mounted on a tripod stand, and it is aimed at this part that I have placed on my granite table. So during the demonstration, you will be able to see projections onto this part for various features. So before I proceed with the demonstration, I have a quick PowerPoint presentation to share with you. So, our agenda for today's demonstration, I will firstly go over a company overview of Faro, and following that, I will give you a system review of the TracerM hardware along with some of the software that we're using. And most importantly, we will share with you the deployment and applications that this TracerM has. And following that, we will proceed into the hands-on demonstration with laser projections onto this demo plate. The total duration of today's demonstration is expected to last about 30 minutes. So I will move on into the company overview. So briefly to summarize, in 1981, Faro started in the medical 3D component industry with the articulating arm technology. And in 94, they transitioned to the industrial manufacturing markets. And over the years, they have come up with various types of product solutions, as you can see. We have a global footprint of offices. Our global headquarters is located in Lake Mary, Florida, in the US. Our European headquarters is located in Germany, in Europe. And lastly, our Asia Pacific headquarters is located in Singapore. So just to give a brief overview of the products in Faro's product family, we have the Edge scan arm, which provides you with both contact and non-contact measurement on part sizes up to about 5 meters in size. Then we have the Laser Tracker Vantage S, which provides you with contact measurements on part sizes up to 80 meters in size, 80 meters. Then we have the Cobalt Array 3D Imager, which actually provides non-contact scanning or imaging of your parts. And point clouds are created for you to do CAD comparison. For the Cobalt Array 3D Imager, if your part size exceeds the field of view for one unit, you may connect them in multiple units together to form an array and scan your part in one scan. Today we'll be going over the laser projector, so I will share the details with you in the later slides. And to round off our hardware, we have the Focus 3DX series, which is a laser scanner used mainly for building information modeling and civil information modeling, as well as crime and accident scene scanning. And lastly, we have the Freestyle 3D scanner, which is a handheld scanner used for mainly product design or reverse engineering. We also have a range of software suites which we use with our hardware, and we also support the use of our hardware with third-party software such as Geomagic and Polyworks. So moving on into the laser projector, our laser projector projects a clear and distinct laser line onto a surface up to 15 meters away, reducing or eliminating the need for real templates or physical templates. For our laser projector, it uses 3D projection technology. So what this means for you is that even when your surface is curved or is not straight or flat, the projection aspect is maintained and there's no distortion. This will also be demonstrated during our demo later. So some of the key features that our laser projector has include fast projection and rapid refresh rate, which means for you reduced flickering. The range of a laser projector can be between 1.8 to 15 meters. And you can also mount multiple units in an array operation to cover a larger space. The design is rugged and robust and allows you to use the laser projector in both a lab environment as well as on the shop floor. And the color of the laser is actually green, which is more visible than the red laser. So there are two types of deployment options, mainly the fixed deployment options, where you can see it mounted on a gantry or on a floor mount fixed telescope. And we also have portable stands such as tripod stands, which come together with I-beam or 3-axis mounts so that you may adjust the projector as it is mounted on the stand. There are four main applications for the laser projector, mainly part positioning and assembly, composites and ply layup, paint and decal templating, as well as visual verification. And I'll be showing you some visual examples for each application. So for the part positioning and assembly, it is used mainly to locate brackets, fasteners, interior panel positionings, to locate welding locations, as well as to position blocks using laser lines for assembly. For composites and ply layup, this is mainly used, for example, in the case of a carbon fiber, where you have to lay various layers of composites together in order to form the final product. So for each individual ply or layer, you can use a laser projection instead of a physical template. So not only does this reduce the amount of time you need for your ply layup work, but it also helps you to actually change the design very quickly without having to wait for a new physical template to be made. Then for paint templating and decal location, for the case of the aircraft body, you can connect up to multiple projectors in order to cover the entire decal along the side of the plane. And lastly, for visual verification, the projector is also good for accurately identifying drilling points, welding points, as well as verification of the placement of your parts after the assembly. So that wraps up the PowerPoint presentation that I have to share with you. And right now, I will be proceeding into the web demonstration for the laser projector. So firstly, I'm going to adjust the the camera view. And if I bring up this operator software, this is the operator software which you will be using during the process of your projection project. So by changing to this camera view, the first thing I want to show is the field of view. So by turning on the field of view, you should notice that firstly, there is a laser line. It actually starts on the floor. So if I move the camera down, you'll be able to see that there's a placement of a laser line on the floor, and it traces back across here along the top of the ceiling, across the top, and it goes back down over here, down the wall. And if you look across the floor, it is on the floor as well. So what this creates exactly is a field of view box for your laser projector. And when you are on site and when you turn on this feature, you'll be able to tell what is the maximum field of view by placing your projector at that particular location. So the idea is that whatever projection you would want to do should be placed within this field of view. Okay, so I'm going to turn that field of view off, and next I'm going to zoom in on the part itself so that you will be able to see clearly. the projection during the process of the demo. So I'll be zooming in here. Okay. And I'm going to the software screen. So the first step that we will need to do for this laser projection is to actually perform a manual alignment. So if you look along the bottom of my software screen, it's located under F6. And the idea for the manual alignment, within the software screen right now, you can see that there are 8 targets labeled TP1 to TP8. And TP1 corresponds to target 1. And if you look now at the video screen, you'll be able to see a green laser dot, and the locations of my target are accordingly TP1, 2, 3, 4, 5, and so on until you reach TP8. So for the manual alignment process, the idea is to use your mouse and trace that green dot that you see on my part to the various target locations. This does not have to be exactly there. You can be within or near the area, and you can click, and it will scan and provide you with a result in the software screen. So as long as you are able to obtain a circle within the crosshair, you can accept the result. And I'll repeat that process for targets 2 until 4. And when I click accept for target 4, the software and projector will actually automatically scan and locate targets 5 to 8. And if it's successful, your screen will turn green, as you can see right now. And this tells you that the alignment is successful and you are ready to perform your projections. So as you can see, the first projection we have is the bracket. And if I turn it on, you can see the bracket projection onto my part. If I take an actual bracket and I place it within there, you'll be able to see that the outlines of the bracket are actually accurately traced out. And this is a 3D projection, so your part does not have to be completely normal to the projector. And at the same time, because this area of the bracket is extending out from the base plane, the laser is able to trace onto these areas as well. So if I move to the next projection, you will see that the next shape that we have is a pentagon shape. So if I place the pentagon part again, you'll be able to tell if your part is straight by using the laser projection lines to determine as such. So the outline is traced onto the pentagon shape as well. Next, we have multiple projections onto or these holes that you see on our part here. So we have 8 holes being projected, and if you were to select an individual hole, they can be projected as well. So now I have a projection just on a single hole within this layer. And if you look along the bottom of my screen, under F5, it says that auto next layer is on. So what this means is that with another retroreflective target, all I need to do is move the target to the line of sight of the laser, and the projection will automatically transition to the next hole. So I can continue to do this, and the benefit of this is that should you be located near your operating part and the computer is all the way back away from you, maybe about 5, 6, maybe even 10 meters away, this can be a way to transition your projection without having to walk back all the way to the computer. So this reduces time and makes it a lot more convenient for you. And it's not just within the same layer. You can use auto next layer to transition to following layers as well. So if I move to the next one, it moves to the next projection, which is the round slot. So if I project to the next one, we have the mold as well. So with mold shapes, again, if I place my mold within here, you can see that it is accurately positioned again, and you can verify it this way. So similarly again for the square projection, and we have it. And I mentioned during my PowerPoint presentation that we are able to project onto curves as well. So as you can see right now, the center the center portion of my part is curved and is projecting accurately onto the curved surface. And if you look within the software view, if I change the view to a 3D rotation and I rotate, you'll be able to see that this is actually a curve projection, and the curve projection is actually accurately represented on our part itself. Now, the last thing I would like to show is the tracing function of this projector. So if I go to focus, if I go to slow motion during my projection, you can see that what's happening right now is that the projector is actually tracing out the trajectory of this particular projection or feature. So how this can be useful is, for example, if you are working on a particularly complex part, uh, whenever you are in a particular projection, this slow motion will help you to easily identify the correct layer to be working on, so that you will not confuse it with other projections or other parts or other layers. And that brings me to the end of what we would like to show you today for the laser projection demo. We hope that you are able to see a certain usefulness for this within your application or your factory. And should you have any questions, please feel free to drop the account manager from Faro in charge of your company any queries. And I wish you a nice day. Thank you very much.